Hello, everyone, and welcome back. Today we are going to be talking about the next subject in our chapter of kinematics, and that is acceleration. So, hopefully, by the end of this short video, you're going to be able to answer the following questions you can see on your screen. What is acceleration? What has to change for an object to accelerate? And how can we determine the acceleration of an object if we are given the object's velocity and time? So the very first question everyone always asks is, okay, so what is acceleration? Tell me, just tell me. Well, my answer to that is this. What is acceleration? Acceleration is the feeling when you're in a car, when you're being pushed back against a seat, or when you're being pulled forward when you hit the brakes too quickly, or when you move to the side when you're making a sharp turn. Just like this poor dog apparently slid back into the seat. Somebody accelerated too quickly. Well, now you're going to say, well, Mr. T, that doesn't really help me. I don't really want to know what a feeling is. Yeah, I know. I just kind of wanted to show this funny picture. I thought it was amusing. The exact definition of acceleration is the change in velocity's rate. For example, when you're speeding up, when you're slowing down, or when you're changing direction. Remember, velocity counts direction. So if you are changing direction, that is also a type of acceleration. So if you are at a red light and you hit the gas pedal and you accelerate when it turns green, that's why it's called an accelerator pedal, is the technical name, because you are accelerating, you are changing your velocity. So when it comes down to it, well, you know what? There's two types of acceleration you can show on a graph. I'll tell you about a third one, but you can't really see it on a graph. It is positive acceleration. That's when your speed or velocity is increasing. So if this were a velocity time graph, it'd be increasing. Negative acceleration, again, velocity time graph. Your speed or velocity is decreasing. So positive acceleration, negative acceleration. Some people call negative acceleration deceleration. I guess that's just another way to say it, but it's still a type of acceleration. So technically, most scientists will say negative acceleration, so they're very specific. Now, there is a secret, not so secret because I mentioned it on the last slide, third type, but you can't really see it on the graph. And what the third type of acceleration is, it's when you're changing direction. Now, in a two-dimensional graph, we can't really show how to change direction, but just keep in mind, see a car speeding up, slowing down, changing direction. Those are all types of acceleration. So, now that we know what acceleration is, everybody's favorite part, the math. How do we calculate it? So, since acceleration is a change in velocity divided by amount of time, you will most often see it written like this. You will see A is equal to V sub F, so that's like a little f below a V, minus V sub I divided by time. Sorry about that. Let's make that look more like a T. So, final velocity minus initial velocity divided by time. There is one other way you can write this, and this is the way most scientists are going to write it. And it's just so you don't get confused. In case you see this or you see me write it, acceleration is equal to delta V divided by T. So that delta, this triangle, is delta. It is the Greek letter D, basically. And in science, or sometimes math, we use that to mean a change happened. So, change. So again, it means the same thing. It's two different ways to write it. Acceleration is a change in velocity divided by time. Change in velocity, so you have the final velocity minus the initial velocity over time. They both mean the same thing, just different ways of writing it. Personally, I like to write it this way because it looks way fancier and you try to impress your friends. So now that we have our formula, acceleration is equal to the change in velocity divided by time, we can use it to solve an example problem. So in this example problem, it says, suppose a car is stopped at a red light. When the light turns green, the car accelerates to a speed of 150 meters per second. The car takes 10 seconds to reach the speed. What is its acceleration? So now would be the time you pause the video, see if you can work this out, and come right back to me. Then you can watch me work it out, see what you need to work on. Remember, use the guess method like we did in the last video. Use guess. It's going to make this a whole lot easier. Okay, hopefully you tried to work that out on your own. And I'm going to work it out right now with you. So this is the first time I've seen this problem too. So let's work this out together. So we have, let's start with G. What are we given in this problem? So, come on, pen, do your thing. Yeah, I got a new pen and I'm still getting used to it. So we are given a final velocity of 150 meters per second. Boy, I'm sloppy today. Apologies. So 150 meters per second. We are given a time. Apparently my pen died on me. I'm back to the mouse time of 10 seconds. And are we given anything else? This is one of the trickier ones. We are given one more thing technically. It's what I call hidden in the problem. So those are the only two numbers they give us. But if you look at the word problem, it says the car is stopped at the red light. So when it's stopped at the red light, you have to realize in your head when something's stopped, that does have a speed. So that would be the initial velocity is equal to 0 meters per second. So we have initial velocity, final velocity, and time. What are we looking for? Acceleration, so A. Next step, so what's our equation? Well, I am going to use this to make it easier to understand. Final velocity minus initial velocity divided by time. So we got that. I'm going to put the second S over here, or first S over here. So let's substitute. Final velocity is 150. Initial velocity is 0. Time is 10. So 150 minus 0 is 150. 150 divided by 10. Our final solution is 15 meters per second squared. So everyone's going to say, Mr. T, how did you get meters per second squared? How did you know your answer was in that? Okay, so I didn't write it out because, well, one, I'm constrained on space here, and two, it's hard enough to write on the computer. But when you're doing problems, if you really, really need to know what the units are, and you should, if you haven't memorized them, the easiest thing to do is to leave the units in the problem. So for example, we know this is 150 meters per second, and we know this is 10 seconds. So you have meters per second on top of fraction, second on the bottom of a fraction. So anytime you have a fraction within a fraction, you can move these around to make it easier to understand. So this second moves to the bottom because you have meters per second over seconds. So it actually becomes meters over second times second. So anytime you have two of the same thing together, you turn that into a square. So that becomes meters per second squared. That's how you give it. So if you leave your units in the problem, it can make it a little easier to understand. Another thing you can just do is memorize that acceleration 99% of the time is going to be in meters per second squared. That's pretty easy too. So those are the type of problems you're going to see for acceleration. So again, unit for acceleration, going to be meters per second squared, written words, or how you're going to see it in the problem. Positive acceleration is a positive number, and it's going to have the upward slope on a graph, velocity time graph. Negative acceleration, negative number with a negative slope on the graph. You can have a negative acceleration. So if you get an answer that looks like negative 9.0 meters per second squared, do not freak out. That's okay. That just means it's slowing down. That's why we care about direction. That's why acceleration is a vector, just like velocity, just like displacement, because it makes a difference whether you're slowing down or speeding up. Negative 9 meters per second squared is a big difference between 9 meters per second squared. And then last but not least, acceleration and velocity, even though they're related, are not identical. So if an acceleration is small, that means the velocity or speed is increasing gradually. It's increasing slowly. If the acceleration is high, that means the object is speeding up rapidly. So for an example, if you watched the video, which you should have, of the Bugatti versus the plane was what, 2, 3 times faster, 4 times faster, 5 times faster? The top speed on it was ridiculously fast compared to the Bugatti. However, the Bugatti's acceleration was much higher. So even though the plane beat the car in the end, if that race would have been half the distance, the car would have won. Why? Because the car's acceleration was much higher. The car reached its top speed long before the jet plane did. Hopefully that makes sense, that even though they're related, they can be different. You can have a high velocity and a low acceleration, or a high acceleration and a low velocity. So, to go back over hopefully what we learned, what is acceleration? That's a change in velocity. What has to change for an object to accelerate? Well, its velocity has to change. It either has to speed up, slow down, change direction. And how can we determine the acceleration of an object? If you remember, acceleration is equal to the change in velocity divided by time. So thank you everybody for listening. I really appreciate it. This is just the basics of acceleration, and we're going to go a little bit more into it later. Have a good one.